This is homework set 45 on sequences, questions number 6 and 7. Question 6 has us working with what is called a recursion formula. And a recursion formula is a formula that produces one term from the one just before it. So let's write down what we have here. We have that a sub 1, this is the first term, is 3. So this sequence starts off with a 3. And now, according to this right here, we can get any term if we know the one before it. Right? Now, let's write this. I'll write that formula. So this says that a sub n, the nth term, is equal to 4 times a sub n minus 1, and then minus 5. Now, what it says is that if the nth, the nth term, right, the next term is equal to 4 times, now n minus 1, that's the number before n, right? If n is 10, this would be 10 minus 1, or 9. So you see, the 10th term would depend on the 9th term. So if I know the 9th term, I can do all this and get the 10th term. So let's use that and get a sub 2. So a sub 2 is going to be 4 times a to the 2 minus 1 minus 5. Now that's equal to 4 times a sub 1 minus 5. And I know a sub 1, right? 4 times a sub 1 is 3. That's the first term. That is given, right? That is given. That has to be given to us. And then minus 5. So this is 12 minus 5. So a sub 2 is equal to 7. Now I'm going to keep track of these terms up here at the top right. So the first term is 3. We did some work. We found the second term is 7. Now, let's get the third term. So a sub 3. Now a sub 3, according to the formula, here's our formula. Just replace all the n's with 3. So I'll get a sub 3 is equal to 4. That's right, 4 a sub 3 minus 1 minus 5. This is 4 times a sub 2 minus 5. This is 4 times, now what's a sub 2? Well, we just found a sub 2, right? That was the work we did before. So a sub 2 is the previous term. That was a 7. All right, so this is 4 times 7 and minus 5. So 28 minus 5. So a sub 3, the third term in this sequence, is 23. So let's write that up here. Third term is 23. Now, what about the fourth term? A sub 4. All right, so this is equal to, now go back into your general formula right here. You know what? I should probably circle that so I can find it every time. Now, this is equal to 4 times a sub 4 minus 1 minus 5. That's equal to 4 times a sub 3 minus 5. That's equal to 4 times, now what was a sub 3? Well, a sub 3, we just did all that work, and we found that a sub 3 was 23. So 23 minus 5. Now, a sub 4 times 23, 4 times 3 is 12, 8, 92 minus 5. So a sub 4 is going to be an 87. So that's an 87. And now a sub 5. A sub 5, that is going to be 4 times a sub 5 minus 1 minus 5. That's equal to 4 times a sub 4 minus 5. That's 4 times a sub 4. We just found that. A sub 4, right, a sub 4 is that 87 right there. Minus 5, right, and this just turns out to be 343. So that's a sub 5. All right, so we get 343. There are the first 5 terms of this sequence. Question 7 tells us that the entry-level salary for a teacher is $34,000, and then the teachers will get a 5% increase every year of service thereafter. So first of all, can you write a sequence for the teacher's salaries for the first 5 years? So we do know this one, right? We do know that A1 is equal to $34,000. Right, that's the teacher's salary at the first year. You know what? I'm going to keep track of these up here to the top right. $34,000. Now, what about the salary in year 2? Well, this is going to be currently making $34,000, but then you're going to add on the raise. Now, the raise is 5%. So it's 5% of times 34,000. All right, this turns out to be 34,000 plus, this is 1,700. Now when you add those together, you get 35,700. All right, that's the salary at the second year. All right, so I'll put that up here at the top right. 35,700. Now year 3. So year 3, the salary in year 3 will be that base salary of 35,700 plus 5% of times that 35,700. So this is going to be equal to 35,700 plus 1785. Make that multiplication, you get 1785. And when you add these two together, you get 37,485. 37,485. And that's the salary at the end of the third year. I'll put that up at the top here. It's going to be 37,485. Now, at the end of the fourth year, so A sub 4, this is equal to 37,485, the current salary, plus 5% of that salary, 37,485. This is 37,485 plus, now this turns out to be 1874.25. That's if I multiply these. And then if I add these together, I get that A sub 4 is 39,359.25. Right, so that's the salary at the end of the fourth year. 39,359 and 25 cents. Right, now at the end of the fifth year. Okay, at the end of the fifth year, you can try that if you like. I came up with 41,327, 41,327 and 25 cents. So I'm going to put that up here. 41,327 and 25 cents. All right, that is the salaries for the first 5 years. Now, the second part of this problem asks us to write a general formula. So given any year, we could just plug that year number in after a number of years after we start and get the salary. Now, when I look for a pattern, I want to look back to what I did. So go back to A sub 2. What do we do to get the salary in the second year? We took the salary in the first year and then added 5% of that salary. Now, if I look at this more carefully, A sub 2, all right, I'll rewrite it again bigger. 34,000 plus 0.05 times 34,000. Now, you see that 34,000 is common to both terms, so I'm going to factor it out. 34,000. Now, if you factor it out, right, take out 34,000, 34,000. 34, what would you put here? What are you going to put here? 34,000 times what gives you 34,000? Well, that's a 1 plus. Now, you had a 34,000 here, but you removed it. So what's left here is 0.05. Okay. Now, this turns out to be, all right, so A sub 2 turns out to be 34,000 and then 1.05. All right, so I made a little progress here. What about A sub 3? I think if we do this one, we'll see what's happening. So you start out here with your 34, this is your base now, 34,000 and then 1.05. That's your base, but then you get 5% of that, right? What are you going to do? You're going to take your base salary now, which we know was just 35,700, but we're looking for a pattern, so we write out all the details. So here's our base salary in year 2, and then we get 5% of that. So it's 0.05 times 34,000 times 1.05. All right? Now, what's common? Well, what's common is that 34,000 times 1.05. So I'm going to factor that out. 34,000 times 1.05. Now, if I factor that out, what's left? All right, well, what are we going to put here? 34,000 times 1.05 times what is going to give us 34,000, 1.05. Well, that's a 1. Plus, now, here's that 34,000, 1.05. If I factor it out, if I remove it, what's left is 0.05. 0.05. So now look at this. This is 34,000, 1.05 times another 1.05, but I'm going to write that as 34,000, 1.05 squared. That's a sub 3. Now I can see a pattern going on here. Look at this. For a sub 3, the third year is 34,000, 1.05 to the second power. Go back up to a sub 2. It's 34,000, 1.05, but just to the first power. So it looks like I'm going to put an exponent on the 1.05, and the exponent is going to be 1 less than the year. So I'm going to write this as a sub n is equal to 34,000 times 1.05 to the n minus 1, right? It looks like the exponent here, the exponent is 1 less than the year. So if this is n, this would be 1 less, n minus 1. So let's see if this thing actually works. All right, so I'll circle it here. Let's just see if it works. What would a sub 5 be? This is after 5 years, your 5th year. The formula that we just said is 34,000, 1.05 to the 5 minus 1. That's 34,000, 1.05 to the 4th. Now, on your calculator, put in this. Put in 34,000, parentheses, 1.05, and then raise it to the 4th power. And I did that, and I got a sub 5 being 41,327.25, which matched just exactly what I had on the last page. So I think our formula is correct. That answers questions 6 and 7 on our homework set 45.